Hey there, and welcome. You see that little 5G icon on your phone all the time, right? But what does it actually mean? Well, today, we're going to pull back the curtain and show you how this whole thing really works.
I mean, think about it. You tap a button and poof, a video from a server halfway across the world just appears on your screen. It feels like magic, doesn't it? So in the next few minutes, let's dive into the invisible world that makes all of this possible.
Okay, so it all starts with something called the radio spectrum. You can't see it, you can't touch it, but it's everywhere. The best way to picture it? Just think of it as a massive invisible highway that carries everything from your car radio signal to your phone's data. And to really get how data travels down this highway, let's use a super simple analogy. Imagine all that data, your videos, your texts, your emails, is water. And the lane it's traveling in, that's a pipe. The size of that pipe, well, that turns out to be everything.
That width, that's what we call bandwidth. It's pretty intuitive, right? A wider pipe lets more water, or in our case, data, flow through at the same time. This is exactly why if you want to stream that 4K movie without the dreaded buffering wheel, you need a really, really wide pipe. You need high bandwidth.
But here's where it gets interesting. Not all the lanes on this invisible highway are created equal. And this leads to a huge, crucial trade-off that engineers have been battling with for decades.
And this is the heart of that trade-off: coverage versus capacity. On one hand, you have low-frequency waves. Think of these as the marathon runners of the wireless world. They can go for miles and miles, and they're great at getting through walls. That's why you still have a signal in a basement. But they can't carry a lot of data, so they're kind of slow. On the other hand, you've got high-frequency waves. These are the sprinters. They are insanely fast and can carry a ton of data. The catch? They have no stamina. They can't go far, and something as simple as a wall can stop them in their tracks.
So that's the big puzzle, right? How do you get the best of both worlds? How can we get that marathon runner range and those sprinter-level super speeds? Well, this is the absolute genius of 5G. It looks at that trade-off and says, why choose? Instead of picking one or the other, 5G uses all of them together in a really clever way. Think of it like a spectrum layer cake.
Let's break down this cake. At the bottom, the foundation, you have the coverage layer. This is that low-frequency stuff that reaches everywhere, even deep inside buildings. Then in the middle, we have the capacity layer. This is the real sweet spot. It balances good coverage with fast speeds and handles most of what we do every day. And then you've got the icing on the cake, the high-throughput layer. This uses those super high frequencies to give you absolutely mind-blowing speeds, but only over short distances in really dense places, like a packed stadium or a busy downtown street.
So using all this spectrum is a huge deal. But 5G isn't just about using more spectrum. It's about using it way, way smarter. So let's look at how things used to work. Old antennas were, well, kind of dumb. They worked like a simple floodlight, just blasting the signal out in every direction, hoping to hit a user. Sure, it worked, but it was incredibly inefficient. You're wasting so much energy lighting up areas where there's nobody.
Now, enter 5G's secret weapon, massive MIMO. Instead of one big, dumb floodlight, imagine having dozens of tiny, laser-focused spotlights. This technology lets the tower create multiple, steerable beams of data and aim them directly at you and your device. It's a total revolution. It cuts down on interference and boosts efficiency and speed like you wouldn't believe.
And here's the thing about this tech. It never, ever stops. Even while we're all just getting used to 5G, the hunt for what's next, for more spectrum, is already on.
You can really see the relentless push forward here. 4G lived mostly down in the lower frequencies. Then 5G came along and made this huge leap, pushing way up into the higher gigahertz bands. And for what's next, maybe 6G? Researchers are already exploring the sub-terahertz range. We're talking about frequencies that just a few years ago people thought were completely unusable for this kind of thing. So you see, 5G isn't just faster 4G. It's a fundamental redesign of how we connect to the world. And as our wireless highways keep extending into these new, ultra-high frequency frontiers, it really makes you wonder, doesn't it? What new possibilities and technologies are we going to unlock next?